So under the block diagrams, you will notice that the block diagrams that we were talking about, most of them only had a single input. But now, in some cases, we can have, in practical cases, we usually have disturbances to a system. And these disturbances are always referred to as inputs. So you'll find that it is often necessary in order to analyze and study a system that has got more than one input that is simultaneously applied at different points. When multiple inputs are always present in a linear system, then we usually use what we refer to as the superposition theory. We use what we call superposition theory. We use what we refer to as the superposition theorem or theory. We can talk of superposition theorem. And when you talk of this superposition theorem, then in this case, the input is always considered alone, while setting others to be zero, and then the final solution is obtained by adding the individual expressions together in order to get the overall output. In this case, in most cases, when you talk of the multi-input systems, you will not be asked the transfer function, but rather you will be asked the overall output of a system. So, for example, we can talk of a situation whereby we can look at it in terms of an example, whereby we can have, let's talk of a system that has got, we can talk of a system that way, whereby in this case, we have G1, we can have G1, then at that point, we have another input, whereby we can talk of that one as mu, that one can be disturbance, then we can talk of this one as G2, then we have that. Then here we can have R of S, of course, then we have H here, we can have a simple H here, we can have a simple H here. So that is what we refer to as a multi-input system. So from here you can see that we have two inputs, we have R of S, and also we have mu of S, which we can consider as a disturbance. So when we talk about this one, then the first thing that you are going to do is that you are going to consider, you consider the input R and you let that one to be zero. So you will simply say that you let mu of S be equals to 0. So if you let that one to be equals to 0, then it means that there is exactly nothing here. We don't have any input at that point. Therefore, we'll have our R of S is, we can talk of our input R of S. Then we have that. So our block diagram will be, and then, of course, these two will now be in series. So we can have our G1 and G2. Then we have an output. Then, of course, we have H. We have H. So in that case, that is now what we are going to have if we let that one to be 0. So after doing that, now we can get, of course, this one is an input with the relation to R of S. Then if it is an input with the relation to R of S, we can talk of it as the output with the relation to R of S. So in that case, we can have now, we can get the overall transfer function. So we can get, say, CR of S all over R of S is going to be given by CR of S all over R of S is going to be given by G. Our G is going to be G1, G2 all over 1 plus, because the feedback, let me just confirm, the feedback was negative. We can have it to be negative, because the feedback was originally negative. So in that case, we are going to have 1 plus G1, G2, H. So if we want to get the overall, the output for that, CR of S is now going to be given by G1, G2, R of S all over 1 plus G1, G2, H. Then again, now after letting that one to be 0, After letting this one to be 0, now we can now let this one to be 0 and then do the same. So in that case, we can talk of let R of S now be equals to 0. So if R of S is 0, then we can redraw the block diagram. Of course, we can redraw the block diagram. And if we redraw, we have mu of S. Then the only thing that is in the forward element, because that one was C of S, the only thing that was in the forward element in this case now will be G2. So we are going to have our G2 here. Then we are going to have everything moving back to the feedback, whereby this H will pick that negative. Then we are going to have at the feedback, we are going to have minus G1H. Then feeding on that, feeding there, and then that is now what we are going to have in this case. So this one is going to be output as a result of mu of S. Output as a result of mu of S. So in that case, we can now get our G. So this one is G2. We can now get the overall transfer function. We can now get the overall transfer function. So the overall transfer function, not the overall, but the transfer function with respect to input mu of S. So in that case, we have C mu of S all over mu of S will be given by G2, which is now our G. Our G will be G2 all over 1. And again, now considering this, the feedback will be positive. So we are going to have 1, and then there will be minus because the feedback is positive. But now, what will be our G? Our G will be so minus into minus G1, G2H. Of course, that is now what we are going to have. Then, if you combine that, if you minus and minus, so we are going to have this one to be equals to G2 all over 1 plus G1, G2H. 1 plus G1, G2H. And in that case now, we can have C mu of S to be equals to G2 mu of S all over 1 plus G1, G2H. And therefore, to obtain the overall the overall output, therefore C of S will be equals to C R of S plus C mu of S. C mu of S. So, which is going to be now C of S is now going to be G1, G2, R of S all over 1 plus G1, G2H plus G2 mu of S all over 1 plus G1, G2H. So that is what you are going to have. So in this case, you shall have obtained the overall transfer function. So by using superposition theorem, considering the inputs alone and then combining the sum in order to obtain the overall output. One thing that you will notice is that in the denominator will always be the same if you evaluate it properly. If you take good care of the minus sign that was there in H. So that is how the multi-input systems work. We are going to look at another example in order to understand the multi-input system further. So we can look at that example. So what you will see is that in this case now we have 3 inputs as opposed to the first case where we only had 2. So if you do that, we are still going to use the superposition theorem. And the superposition theorem states that you are going to equate other inputs to 0, and then you only use 1 at a particular time. So what are we going to do in this case? We can start by looking at the first case. we can assume so you can say in the first case, the solution, you can let d1 of s be equals to d2 of s be equals to 0. So if you let that one to be that way, if you let that one to be d1 of s to be equals to 0, then what we are going to have is a block diagram like this, whereby we are going to have r of s, then to that manner, then we can have this one and that one will now be in series, so we can talk of s into s plus 2 using the block diagram method, so that we have that, and of course c of s. Then from there, this and that also, we are going to have minus here, then here we are going to have s all over 8 into s plus 1, then that is now what we are going to have in that case. So that is now going to be the block diagram. Of course, we have just combined that one and that one in series, that one and that one in series as the feedback in order to obtain that. And then from there, we can obtain the transfer function for this. Of course, already it is in canonical block diagram form. So we can go ahead and get the overall transfer function. So we can go ahead and get the overall transfer function. So here we can look at that. So if you get that, so we know that for us to get that, we are going to get C with respect of input R of S. So that is going to be C with respect to input R of S. So that's going to be that all over R of S. And that is going to be our G. Our G is going to be S into S plus 2 all over 1. That one is minus, so it's going to be plus GH S into S plus 2, which is still our G, and H, S over 8, so it's going to be S squared, then all over 8, S plus 1. So that is what we are going to get, of which if you simplify that, then we are going to get something like S, 8S, so that is going to be 8, and we are going to get 8S, we're going to get 8S into S plus 2 all over S squared, so that one, S squared into S plus 2, S plus 1, S plus 2, S plus 1, then plus 8. So that is what we are going to get as far as that is concerned. And of course, for us to get the output for that, our CR of S is now going to be 8S plus 8S into S plus 2 all over S squared into S plus 2, S plus 1 plus 8, and of course we multiply by R of S. So that is the overall, the output when we consider that one, when we consider D1 of S and the D2 of S to be 0. So that one you are through with the first output. The first input, you go to the second input, that is D1 of S. So in that case, we are going to let R of S to be equals to D2 of S to be equals to 0. And if that is if you do that, then we are going to have D1 of S, then the output will only be having S, so we have D1 of S, then there, going to that, so that we have S there, then we have an output, and this output will be C D1 of S. Then everything will be at, all this will be at the input, we will be at the feedback, taking the care of the negative in that case. Of course, now it will have a positive feedback, and this one is going to be minus S over 8 minus S squared. We can have minus, so this is what we have, so it's going to be minus S all over 8 into s plus 1, s plus 2. Then that is now what you have as your feedback. So in that case, that is now what we have. So we are supposed to evaluate and get what we are going to get as the output. In that case, we can get what we can see what we are going to get as the output. So in that case, we can talk about C d1 of s all over d1 of s is equals to, our g is going to be s all over what is going to be all over 1 minus now into minus into and again minus s squared all over 8. So this s for the g, that s for the g, into s plus 1, s plus 2. So that is what we are going to have, of course, that one. So then we can talk of c d1 of s all over d1 of s is going to be given by, so if we evaluate it properly, then we are going to get that one is going to be 8s all over 8s all over s squared into s plus 2, s plus 1 plus 8. So that is what we are going to have, and therefore c d1 of s is going to be given by 8s all over s squared plus s squared into s plus 2, s plus 1 plus 8, and of course d1 of s, d1 of s. So that is what we are going to get for that. Then we can get to the next part whereby we are going to now obtain when we consider this and that to be 0, so that the only input that is there is this. So in that case, we can say you let r of s be equals to d1 of s be equals to 0. So if we do that, then of course it is going to start from here. Then it means that we have start from here in that manner until the output. So it means that the only thing that is in the feedback path is s plus 1. The rest are in the forward path. So in that case, we are going to have that. So we have d2 of s, d2 of s. Then here we are going to have minus s squared minus s squared all over 8 minus s squared all over 8 into s plus 2 into s plus 2. So that is what we are going to have in the forward path. That one is this up to c. Then the feedback we are going to have, of course, is going to be cd2 of s. So at the feedback, which is positive, we are going to have s plus 1. We are going to have s plus 1. So that is what we have in that case. So if we evaluate it, then of course then of course we are going to have c d2 of s, c d2 of s all over d2 of s will be given by g. Our g is going to be minus s, is going to be 1 over s. It's going to our g is going to be minus s. It's going to be minus s all over 8 minus s squared. Then we have s plus 2 or that is going to be our G over 1 plus GH1, and because it is plus, it's going to be minus into minus again, S all over 8 squared into S plus 2, then again S plus 1. And that is now what we are going to have. That is our G times H. So if you evaluate that, then if we evaluate that, then we are going to get minus S squared. So we are going to get C, which is equals to minus S squared. So we are going to get minus S squared into S plus 2 into S plus 2 all over minus S squared into S plus 2 all over S squared plus S squared into S plus 2 into S plus 1 and then plus 8. So that is what we are going to get. And therefore, after that now, you employ, of course, this is now going to be our CD2 of S is going to be that one D2 of S. So in that case, our that is now the expression for CD2 of S. So from there, we can now get C of S, which is the overall output, which will be given by CR of S plus C D1 of S plus C D2 of S, which is simply going to be what we had before. That is what we had before, which was 8S. We had 8S, so it's going to be 8S into S plus 2, and all of them are under common denominator, plus we can talk about 8S over that, all over, again plus 8S minus S squared into S plus 2, then all this should be over common denominator, which is S squared into S plus 2 into S plus 1 and plus 8. So that is the overall, of which in other ways, this one can be put under different denominator, this one can be under different denominator, that one can be under different denominator, so that this one, of course, we can talk of D1 of S, or we can talk of R of S. Let me just write it so that one is going to be, we can rewrite it so that we have 8S, can talk of 8S into S plus 2, so that is C of S, our C of S is going to be that, all over S squared plus S squared into S plus 2, S plus 1 plus 8, then that one, see that one is R of S, plus, we can put it into bracket, and that is R of S. Can have that, R of S plus 8S all over S squared into S plus 1, S plus 2, plus 8, again the whole of this, you multiply by D1 of S plus, now it is not plus, it is minus S squared into S plus 2, minus S squared into S plus 2, also over S squared into S plus 1, S plus 2, plus 8. Then that one you multiply by D2 of S. So if you do that, then that is the overall output, and you shall have answered, evaluate the output of the system shown. So you have to consider this separately, consider that separately, consider that separately, get their corresponding outputs. Then later on, sum them up. And that is what we refer to as superposition theorem. So that is much we can do as far as block diagrams are concerned. So if you need materials for this or further examples, you can go to www.ees.education. You will be able to obtain the materials as far as these are concerned.